Hey everybody, today's video is going to be kind of unique. We're going to reactivate an old activated neutron irradiated dime from the Museum of Atomic Energy. Before going into a whole bunch of detail on this, in fact, I'm actually in lieu of a whole bunch of detail, I'm going to recommend that if anybody is interested in the science behind this or the history of these dimes, that they go to the Oak Ridge Associated University's website that speaks all about the neutron irradiated dimes from the Oak Ridge Museum of Atomic Energy. That link is in the description below, and it's highly encouraged. Okay, so before I get into a whole bunch of stuff here regarding how I'm going to do it, I'm going to tell you a little bit about these dimes. They are 90% silver content, unlike the dimes of today. I believe around 1965 or 1966, you can correct me if I'm wrong, I believe that's when the silver content of the dime switched over to something other than silver. So the older dimes contained 90% silver, and the rest was copper, and I believe maybe some other type of element, but it was mainly 10% copper and 90% silver. And if you can see, this dime, which I'm going to use to re-irradiate with neutrons, is from 1943, right in the middle of World War II. It's the classic mercury dime, and it pops out of the plastic container just like this, and which makes it really easy for what I'm going to do. Now, this particular dime was probably irradiated around 1963, 1962, based upon its container, and or kind of like a poker chip. And these were more common during the World's Fair during that time, which they did hand these things out as souvenirs. And but the older ones, these were more common in the late 1940s to 1950s, and these were handed out at the museum after they were irradiated. And if you can look, this date here is 1946. That doesn't mean it's irradiated in 1946, but it does definitely mean it has the 90% silver content. Reason I'm not going to activate this one is it's actually pressed into this tin or aluminum sort of housing, and it's got a plastic sort of cover over the top, so I don't want to damage this one. But this one makes it very easy to work on, and I can kind of demonstrate what's going on after I activate it. Okay, so for the purposes of this experiment, I'm going to use the Fusor, the same one that is profiled in all the previous videos that I recently made, aka Fusor 2020. And the video just before this, I activated a silver plate spoon, and then I activated some other elements in other videos prior to this. I believe copper and aluminum and manganese, indium, and I think that was about it. Now I've done I've done silver activation several times before, and I do kind of like using larger pieces. And the reason why I like using larger pieces, about a 1 by 1 inch square, and here's one I rolled out, is because the surface area is larger and it gives you a much larger count rate because of its larger surface area. And so when you measure it with a pancake, you can see it covers a lot more acreage on the face of the pancake detector. But with the dime, you don't really get that much surface area of activation. So I don't expect to get a whole lot of counts from this. Now I am going to radiate this thing with about 1.3 million neutrons per second. That's a rough guesstimate based upon previous calibrations that I have done. But I doubt I'll get much more than, maybe, if I'm lucky, I'm hoping for about 500 counts per minute. And I'm going to have to move fast because this has a half-life. Its very active half-life is going to be over with in about 25, 22 seconds. And then it'll just kind of slowly decay after that and probably drop down to nothing within about 5 minutes. Okay, so here's the moderator, and from the neutron detector tube here in the middle to where the grid is in the middle of the fusor within this black box is approximately 17 centimeters. So we're going to take the 1945 mercury dime. You just drop it right in there like that to line it up to about where the grid would be. And I'm just going to tuck this all in there nice and tight. And we'll put the lid on it. And away we go. There it is, tucked in there. So let's go ahead and fire this up. Okay, well there you have it. Looks like I got to about maybe 350 at one point counts per minute. That's not too bad considering the small size of the dime. Another thing to take into consideration is these are 90%. The previous activation runs that I did use sterling silver, which is 92, I believe, 0.5%. And the flat piece of foil that I showed you earlier, that's almost pure silver, and because it was rolled off of an ingot that I had, and they do provide a lot higher of a count rate due to their purity. So anyway, it looks like it was a success. I'm not going to complain over 350 counts per minute, and you got to see the decay rate go from 350 down to essentially background where it is right now, and so that's about it. I doubt I got much copper activation out of this. I could put it in the gamma spectrometer, but that small amount of copper would be very difficult with a standard sodium iodide gamma spectrometer system. So, but we'll see. Maybe that'll be a future video. All right, if you got any questions, feel free to ask. And again, don't forget to check out the Oak Ridge Associated University's website at the link below for all the details on the neutron irradiated dimes from the Museum of Atomic Energy.